All right, welcome back. Tonight we're going to do sections 4.4 and 4.5. And this is on trend lines and domains and scatter plots. So we're going to start here with this first equation. And if we're given a domain, that means only this set of numbers is what we're going to look at. So we're going to plug, remember domain is the x. We're going to plug those in for x and solve for y. Now this equation, to me, it's easier to solve for y by adding x and then dividing by 2. So it's 1/2 x plus 3. To me, that's easier to plug in. So my range, when I plug -4 in, I get -2 plus 3, which is 1. When I plug -2 in, I get -1 plus 3, which is 2. When I plug 0 in, I will get 3. And when I plug 2 in, I'm going to get 4. It is linear, so it'll continue that pattern. You can write this as a solution set. So our ordered pairs are -4, 1, -2, 2, 0, 3, and 2, 4. So that means -4 gives us 1, -2 gives us 2, 0 is 3, and 2 is 4. It just asks to graph the limited domain. So those are just dots. We're done. That's our graph. There's nothing more. It's kind of like if on a number line you're supposed to graph x equals 1, all you do is you put a dot at 1. That's totally different than x is greater than or equal to 1, which means you have the closed circle and the arrow to the right. That's where the closed circle comes from, the equal piece. So we're just going to put the 4 dots for the 4 points that we have. We're going to do the same exact thing now for the second problem. And since we're given a domain, this bracket is the set of numbers, we're just going to graph those 5 points. Absolute value makes everything positive. Therefore, in my range, -2 becomes +2, -1 becomes +1, 0 stays 0, 1 stays 1, 2 stays 2. My solution set of numbers that I'm graphing is -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. End of solution set. So I'm going to graph that one in blue. 0 gives me 0. 1 and -1 both give me 1. 2 and -2 both give me 2. And you're done. You are just graphing the domain listed. That's it. Now, this one says for an extended domain. So that means we're going to graph this for everything that will make it work. So the first equation, I'm going to rewrite in y equals form. I like to always think of these as y equals mx plus b. B is the beginning, m is the slope. So that means since b is the beginning, if I plug 0 in, I get 1. And as we're going up by 1, our slope is 2. So when I plug the 1 in, I'll get 3. 2 will give me 5. 3 will give me 7. Each time it's going up by 2. That is your m. You can plug the numbers in and solve, like if I plug 4 in, 4 times 2 is 8, plus 1 is 9, or I can just know that it has to be 2 more. This time we're going to connect everything, so 0 gives 1, and then remember rise over run, so it's basically like over 1 up 2, over 1 up 2, over 1 up 2, over 1 up 2. And then we're going to draw the line, because it's the extended domain. Whoa, just pretend that's straight. And it's all of the numbers that make that work. So our domain is all real numbers, because I can plug any x value in and it'll work. I'm going to make that double R, and that means all real numbers. Alright, we're going to graph the same exact thing. Not the same exact thing. On the same exact graph, we're going to graph this one. So I'm going to start at 0, which will give me 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. But x squared is unique because in the negatives, it comes back up. So negative 3 squared is 9. When I plot this, 0 gives me 0. 1 and negative 1 give me 1. 2 and negative 2 give me 4. 3 and negative 3 give me 9. So we're going to draw our curve that is symmetrical, swooping upward. Again, the domain is all real numbers. I can plug anything in for x and anything in for y. The other x, I can plug anything in for x and I will get a y answer. The range for this is not all real numbers. The range, I'm only going to get y values that are greater than or equal to 0. But the domain, x is all real numbers. I can plug anything in and get an answer. And it is a function because it does pass the one-to-one test or the vertical line test. All right, so when we collect data, we're usually looking for some sort of patterns. The data is not always the best. Like number of letters in your name and age, that probably doesn't have a whole heck of a lot to do with each other. So this is probably going to be no correlation. So if we look at this positive correlation, we can draw some sort of best fit line that's showing this data. Now a best fit line has to hit at least 2 points. You want about the same number of points above and below. And it has to follow the trend of the data. So you want these points as close as possible to the best fit line. This is supposed to be straight here. So I've got pretty close to the same number above and below. I've hit at least 2 points. I tried to hit this one and this one. You don't necessarily have to hit the lowest and the highest. You might hit 2 middle points. Once you've made a best fit line, and we'll get to this shortly, you can use the 2 points to write your slope and write your whole equation. Negative correlation is a negative slope, so our best fit line would be going down. And a lot of times if you grab a ruler, which I know that you can't see here, but if you grab a ruler and line it up, like I'm thinking my best fit line is going to go through this and this. Like so. And the last one is no correlation at all. We can't draw a best fit line for that. It's not linear whatsoever. There are things that are best fit curves. Like if you have a graph and it looks something like this, I mean that does definitely look like a best fit curve. So you can draw best fit curves. So this does have correlation, but this has no correlation at all. Can't really think. It looks kind of like a circle, but no correlation for now. All right, so if you look at this, we have positive correlation. I'm going to pick 2 points to make this best fit line with. It looks to me with my ruler that I'm going to go here and here. Now, this is not the only best fit line whatsoever. There are way more best fit lines than this one. But that's what I chose. So, now my point is 2, 3, or pretty close to 2, 3. I'm just going to say it's exactly 2, 3. And this point right here is going to be 7. Let's see. 7.5. So if we want to find the slope of our best fit line, we can do rise over run. So 1, 2, 3, 4.5, and this is 5. This is my rise, and this is my run. So our slope is 4.5 out of 5. That's a number just below 1. And my beginning, it looks like my B is a number just below 2. So maybe like 1.8. So my equation would be something like that. 4.5 out of 5. I'll grab a calculator. So 0.9x plus 1.8. So that's my best fit lines equation. There's more than one right answer. If I wanted to predict what 20 would give me, I could either extend this line and extend this over, or I could plug 20 in and get an answer. That's positive correlation, so it should be going up. If not, that's not okay. And that's actually it for tonight. So, I'll see you tomorrow.